Hello everyone, welcome to Start Tech. So from today we are going to start some series for Spark streaming. So let us begin with today's video. So this is the agenda for the upcoming videos for Spark streaming. So stay tuned. Today we'll be discussing what is streaming data, what is Spark streaming, and how Dstream works under the hood, and other points we'll discuss in our upcoming video, so stay tuned. So what is streaming data? So first of all, before going into Spark streaming, we'll understand what is streaming data. All of you may be knowing, but why is it important? The why part we'll understand, like why the business get impacted due to this. So we already have batch processing systems. We get the data, we analyze, we do some group by, we do some joins, we get some analytics out of the data in our batch processes. But through the batch processes, the problem is that the user cannot take real time decisions. Or if you get a message, you swipe a card and you get a message after 2 3 hours, so that is a delay, right? And you won't expect this to happen in the real time system, and where we have so much of technology in place. And so that is the reason why companies are now moving towards streaming data analysis, and why it is useful. So this is the reason why it is useful. In real time, in quick seconds, a user can make a decision. Like we get a data, user gets a data in his Twitter, and he want to do some sentiment analysis or something like that. So the it's endless, and there are use cases coming for streaming data much more than for traditional batch processing. So what is Spark streaming and how it is achieved in Spark? So there are two ways we can achieve in Spark, that is using D streams and using structured streaming. And we'll also discuss what is the difference between these two. So how it flows, so we get some data, like we get some data in files through through HDFS or S3, or we get some data from Kinesis, that is AWS service similar to Kafka. And we get data from Twitter. So if a company wants to analyze their sales of the product, so they get some data from Twitter and then do some sentiment analysis through Spark streaming. And then finally they dump the data into HDFS or any databases. It can be anything, and finally it should show some dashboard through maybe click view or any other dashboarding system which the user wants. So why what are the other streaming engines, right? So Storm and Trident, these are the old systems. And interview, this is also highly asked interview question, like what is the difference, and what is Storm and what is Trident, what do you know about it? So it's a streaming engine. It's deprecated and it's not used much, but there's a lot of questions asked, like what is Storm. So you can mention that these are the points, like it's so what is the disadvantages of using Storm, I will mention. Like it does not guarantees it only guarantees at least one, not exactly once. So consider that a Twitter data comes in, and you process that data, and you are doing some count operation, suppose for example, and that count may be doubled, or it's not exactly once, it is at least once. So this is the this is why Storm is deprecated, and Spark streaming and D streams and structured stream offers exactly once. So through which it's not doubled, or there is not mutated state and loss. So these and may update multiple times, so that gives burden on the system and it's not correct. So that is the reason why people are moving towards Spark streaming. But what is Storm, you should also know, like this is a streaming system previously used, and Trident is the one which is used for transactions. It's not used as of now, like not most of the companies use Storm and Trident these days, as they are moving towards cloud, and we have Spark now, which is more powerful than Storm. And the disadvantages is like it may be doubled and mutated multiple times, the record gets processed. So that is the reason why companies are moving towards Spark streaming and not Storm. But you should know about this. Trident is has been built on top of Storm itself for transactional updates. It provides exactly once, but pre-state transactions, like if you are doing some stateful operation, this is not handled that good in Trident. So that is why people are moving towards Spark streaming. So what is Dstreaming? Okay, so basically we have streams of data. Consider Twitter data we are having. We do some filters, so we do it in a batching system. So we get Twitter data, tweets, continuously streaming tweets we get. So what Dstream does is Dstream divides it into small batches in seconds or minutes, that is configurable, as you can see in this diagram. So this is the record which is coming from a Twitter data, consider, and we can define the seconds or the window, and that gets divided into RDDs in Spark. Okay, so this is how Spark streaming works for Dstream. In case of Dstream, so what are the all operations? Suppose tomorrow your lead comes, your leader comes, and software lead comes and tells you, like, we need to define all this and we need to transform it. So what are all the steps that you should know? This is also highly asked interview question, what are the steps? So here the steps are like streaming context, which we need to create. It's similar like a Spark context. Okay, and we need to define the seconds, like how many minutes, in minutes you will want to stream, or in seconds, what is the window. So this you need to define. Then what will be the input? For example, in this example we are considering we do a netcat command from a local host, and we are streaming and finding the doing a flat map or some count operations over it. So first step, creating a streaming context. Second is know your source, which source you are getting. Are you getting from Twitter or other any streaming operations, or any file coming every 10 minutes in your system? That could be a case. So here we need to define the source. Then what all the operations you will do, what are the aggregations you will do, and how it would be done. It's like you write all this, then you start your stream, then you get processing the data, it would start computation, and then await termination, like you will wait it for till it terminates, till the stream stops. So this is the overall flow. What are the best practices for using Dstream? So what you should consider. So as you saw in the previous slide, that we define the time interval, right? So that you should consider, like how many time, what is the specified time, how many threads will be there, the number of threads specified for the receiver, and it should be same as a receiver and producer, the data produced and the receivers. Setting the right batch intervals. With multiple D streams, it would be converted into RDDs. So eventually it would be RDDs, and hence you need to define that, and then after it would be union for small added. So in a interview question, in an interview perspective, suppose like your stream, this question may be asked in this way. Okay, so if you are getting a Kafka streaming data, okay, and it the size of the data is low, so how would you handle this? So you can do a union of these all these streams which are low in size or smaller. Like, why to increase the overhead to the HDFS? Suppose you are storing it in a HDFS, so why to overhead the HDFS? So you can do a union for and form a bigger RDD. So this is also interview ask question, like how you can do this. So this is the way you can do it. Okay, moving on. So what is the flow of the job for a Spark streaming application? So we saw all the steps what are involved, right? These are all the steps what are involved. Then under the hood, how the Spark job gets streamed, like what are all the operations and how it is defined under the hood, how it flows. Okay, we will see that. So first step, it would create a Spark streaming context as we saw. Then it will launch receiver, which are the task running under the executors. Input is cached into memory and also replicated to the executor for fault tolerance. We will in detail see how fault tolerance is handled in a Spark streaming application in our next video, so please stay tuned. Then by default it is replicated to two nodes, and streaming context would run without the job. Like you have defined the job for 10 seconds or 1 second or half an hour, whatever it may be. Then and finally the output is dumped into the destination. So how this all happens, we will see in a diagrammatic way. This is the theoretical part I'll told you. So here we have a streaming context, we have a Spark context, we have to consider this as a these are the two worker nodes. For now, you get the data, we get some Twitter records or your file records or log records, right? And what it does under the hood is it keeps a memory buffer, and all the long running so records are pushed to the pushed into executed task, right? And this all is connected to through your streaming context. Finally when the worker nodes are finished with their task, even like some aggregations and all, they are finished, so they will return the result to the streaming context. And streaming context, like when we are done and we want to dump the data into HDFS or AS3, then we do it via Spark context. Streaming context under the hood, these are all the operation which happens, and the result is stored into the final destination. So that is how it is. So for now, let's wrap it up for today. So in a summary, what we did today is we understood Dstreams, what are Dstreams, how the job flows, and how are the context, streaming context and Spark context talk to each other through the task. So in our next upcoming videos, we will discuss other topics like how fault tolerance it achieve, how it is beneficial using Spark, structured streaming in Spark. Okay, thank you for your time today, and we'll see you in the next Spark streaming video. Bye bye.